All right, let's look at Chapter 7 for exam number 2. This was kind of an involved chapter, had lots of different kinds of information that it was trying to introduce, and it can definitely be a little more involved and a little more confusing if you're not familiar with these concepts. So let's start with the meat of the problem here, which is problem solving. So we have George Polya and his process for problem solving, which is a series of questions that that we ask ourselves, that we ask each other, that we ask our project managers, whoever's responsible for this problem solving process, and then in order to better inform our own understanding and work toward a sufficient solution for this problem. So the first step in the problem solving process is to make sure that you understand the problem, to ask questions, to get out there, gather as much information as you can. The second step is to actually devise a plan for your solution. This could be leveraging any solutions that you've seen before for similar problems, any sort of related problems that you've seen, any theories or practical examples that you've seen in other places, things like that. Third step is to actually carry out the plan, either to implement the program, to create that new advertisement, whatever you're doing. And then step 4 is to look back and evaluate how well your solution actually solved that problem. So there are a number of different ways that you can address these kinds of problems in computer science. The method for solving a problem within computer science is a little different from George Polya's problem solving process. On page 202, we break up those 4 steps into a couple different sub-phases. So the first phase, which would be considered understanding the problem, we break down into analysis and specification. So analysis, understanding the problem, making sure that we know everything about it that we can, and then the specification is to explicitly lay out what a successful solution would look like. So this, to say these are the parameters that we're operating under, and this is what we expect the solution to do. Designing the solution is phase 2, also called the algorithm development phase, where we would actually lay out our the design for the program that is going to solve our problem, and then we do some initial testing. Testing is very important. It actually shows up multiple times within these phases because you can never test often enough. There are so many different factors that go into software development, both from a coding standpoint and a user standpoint, that there's always going to be something new that pops up that you need to account for. And it's impossible to identify all of those different situations from the outset. So you constantly need to be testing. So in phase 3, the implementation phase, actually creating the code, actually writing the code, and then you do even more testing all the time. The maintenance phase, phase 4, is the same as reviewing your solution from George Polya, but now we actually use the program and then perform maintenance, which is fixing any bugs that pop up or addressing any customer concerns, things like that. So there are some very distinct parallels here, but for computer problem solving, for software development, it does get a little more involved. So we've heard about this word before, algorithms. But what does it actually mean? An algorithm is, at the highest level, simply a set of steps that are used to solve a problem. And in computer science, there are many different, very common problems that we call patterns that are used all the time, over and over, to solve different problems, because computer scientists are very opinionated about reinventing the wheel. So if you have a very common problem, there should be a very common, understood, accepted solution. But then every once in a while, even if there are solutions that exist for a common problem, it's never going to exactly match your situation. So you have to be able to take these sample solutions, these patterns, and kind of modify them a little bit to fit your specific situation. So we have a number of different algorithmic components here that you can use to set up your problem-solving process, to be able to to work through these steps to say, okay, first you do this, then you do this, then you do this, and it will generate the solution that you're looking for. So the first step, or the first set of components, were called selection statements. If you've taken a programming class, and you should be familiar with this from your programming game homework assignment, a selection statement is basically just a single condition, and then if that condition is true, you do one set of statements, and if the statement is false, then you execute a different set. There are also repetition statements, which we call loops, and those can be either count controlled, which means you just perform them a certain number of times, or they are what we call event controlled, which is some other condition. Either we're waiting for a certain variable to be true, to equal a certain value, we're waiting for input from the user, some other event other than simply just execute this X number of times. So pretty straightforward stuff. And then there's this idea of composite variables, where instead of a variable holding a specific value, such as a number or a string, some sort of text, it holds a more complex sort of object. So the examples they give you are arrays, which are just multiple values of the same data type, either a set of numbers or a set of strings, or whatever, or an object called a record, which is basically, it just represents some sort of entity with multiple properties. So the example that they give is an employee record, which has an internal variable then for the name, the age, and their hourly wage. So anything like that. And these are very, very basic concepts. Depending on the sort of programming language that you use, you may have seen these before. The terminology is very generic. The term variable is obviously universal. Objects, anything like that. You're going to see these a lot when you're writing code. The chapter also introduced a number of established algorithms. So as we said before, very, very common problems will then generate, the community will then generate their solution for these problems. So if you have a collection of variables and you're trying to find a specific value within that collection, then that is what is called a search operation. And we have a number of different algorithms that address searching. You do not need to know the explicit steps of these algorithms, but at least to know the high-level information about these algorithms and how to tell them apart. So sequential search is simply starting at the beginning of the collection. If you imagine all of the values in a row, and you start at the beginning and you step through each one until you find the one that you're looking for. It works much better if the collection is sorted, so the values go from smallest to largest, and then you know that if you pass a certain point, so let's say you're looking for a numeric value of 12, and you are stepping through the collection and you hit an entry in the collection with a value of 15, then you know everything past that value of 15 is going to be larger than 15, and the value I'm looking for is 12, and I haven't found it yet, it's not in the collection. So you're able to do what's called short circuit logic by drawing conclusions about the rest of the array, and then you don't have to step through the entire array, you can just stop there. So sequential search, just stepping through each item in a line, and then if it's sorted, then you can just stop whenever you hit an element that has a larger value than what you're looking for, because it's not in there. It's not in the array. So let's see. Binary search is on page 218. Again, binary search assumes that the algorithms in the collection are sorted. So basically, you start in the middle and determine if the value that you're looking for is either smaller or larger than the value in the middle. And if it's smaller, then you go to the middle of the half on your left. If it's larger, then you go to the middle of the half on your right. And then you just keep bisecting the subsequent halves of the array until you narrow in on the term that you're looking for. And if you get to the point that you've made your whole way down and there are no more halves to check, then the element is not in the array. So we talk about searching with the assumption that your array is sorted, but how do you actually sort an array? So we have